Hi, good morning, everyone. This is Adam Benzion from Hackster. Thank you very much for joining us in today's webinar with Google. Today we're going to talk about Android things. A lot of you already know a bit about Android things. Google have launched the new operating system for the Internet of Things. I love one of Google's taglines around this new product, this new piece of software, that if you can build an app, you can build a device. So I really look forward to enjoying this webinar with everybody today. And this was one of our largest actually ever webinar in terms of registrations. Over 800 people actually registered for this event. So this should be fun to be part of and moderate. Before I introduce our speakers from Google, I'd like to share a few things with you. We are going to record this webinar. We are recording this webinar. So you'll be able to watch this later as well. We'll post it on the Hackster site. Because we have a lot of attendees today, we probably won't be able to answer all the questions that you'd like to ask. So what I'll do is I'm sharing right now in that little chat box the Google Hub on Hackster, and there's a little place over there that you can actually engage and ask questions. It's like a feed. So if your questions are not answered today during the webinar, and I'll help moderate the questions, please do go ahead and use that link and post your questions over there. Okay, so we have 40 minutes of presentations and demos, and then we have about 20 minutes or so for Q&A. So without further ado, I'll introduce Dave Smith and Wayne Pekarsky. They are both super talented developer advocates at Google. They're working on IoT and different other focus initiatives in Google, and particularly on the Android Things platform. So I'll hand it to Dave and Wayne to take it away, and I hope you enjoy the show.
Awesome. Well, thank you, Adam. Hi, everyone. As Adam mentioned, my name is Dave Smith. I'm a developer advocate on the IoT platforms team at Google with a primary focus on Android Things. And I'm joined by...
Hey everyone, good morning. My name's Wayne Pekarsky, so I'm also a developer advocate. I work on Android Things and also the Google Assistant, so we're really excited to be here today to give a little chat.
Awesome. So as Adam mentioned, we're going to talk to you today a little bit about Android Things. We're going to describe to you sort of what this platform is, if you've never heard about it before, how it fits into the IoT ecosystem, and sort of the problems that we're trying to solve with this platform. And then towards the end, if we have time, I've also got just a quick demo that I want to show you so that you can kind of see this platform up and running in action. So let's go ahead and get started. So what is Android Things? Most of you are probably familiar with Android already, right? Android is a mobile operating system that was originally developed for phones and tablets. But since then, we have extended the Android platform to a variety of other form factors, such as Android Wear, Android TV, and Android Auto. And now we've introduced Android Things as yet another extension of that platform into a new vertical or a new form factor. In this case, Android Things is representing the embedded or the IoT type devices. And really our goal with the Android Things platform is to accelerate and simplify the development of these devices in a similar way that we have helped simplify the development of mobile apps on consumer devices in traditional Android, similar to what Adam said earlier. So, now that we know a little bit about what Android Things is, where would you potentially use it? So this is an interesting question to think about when we talk about IoT, because the IoT device landscape can cover a very wide range of hardware with various capabilities. And so when you think about Android and therefore Android Things, the class of hardware that is required to run the Android operating system makes it fit very well into IoT use cases that require some significant amount of compute power running on the edge device. So this is good for applications like security cameras or a smart doorbell, something where you might have to do a fair amount of local image processing on the device from data coming off of a camera sensor, where you might need a good amount of compute power to be able to do that processing without having to consistently go back and forth to the cloud. In addition to that, it also works very well in aggregation type use cases, things like gateways and routers, sensor networks where you may have a large array of very low power simple devices gathering data, they can feed that data back to, say, an Android Things device acting as a gateway, so that it can process that data locally, maybe make some decisions, and then potentially communicate some of that information back to the cloud. So it works very well in those use cases where you need to have a significant amount of compute power running on that edge device. And as we move forward through IoT, this becomes more and more important as we realize all the things that a local device has to be able to do on its own without necessarily being able to constantly be able to connect back to the network all the time. All right, so how are we planning to actually do this with the platform? Really, the goal of Android Things, as it says here, is to help developers build devices from the prototype stage and move them quickly and efficiently into production. So we're not just about providing yet another operating system on a device that you can use to easily build some application. We also want to provide you the tools to take that application and actually produce a real product that you can ship in the market and keep maintained over time. So we're going to talk about all the different things that Android Things provides to be able to make that easy for you as a developer. So it starts with the software that is actually running on the device. So Android Things, as I mentioned before, is a variant of the Android operating system, which means that as a developer, you have access to the full Android SDK and all of the rich APIs that are available to mobile app developers today. You can also use those same APIs to build your applications for your embedded or your IoT use cases. These are things like the multimedia APIs for audio and video processing, camera APIs, network management functionality, access to low-level hardware like USB. All of these APIs already exist in Android today, and you can now use those exact same APIs that have given mobile developers so much success in building IoT applications as well. In addition to that, we also provide you access to all of the developer tools that have made Android developers so successful, like Android Studio. So Android Studio, if you're not familiar with it, is our development IDE that allows you to write the code for your application, deploy it to the device, but it also is fully featured with system profilers, debuggers, and other tools that allow you to really tune and profile and manage your application. And all of these tools have been honed and matured over time for Android development, and now we're bringing that to the IoT ecosystem as well. We also have a host of Google services that are available to you as part of Android Things. And this is actually something that's important that I want to focus on for a minute, because if you think back, or if you've been in the embedded space for any amount of time, Android has actually been a very popular operating system already in embedded use cases and in some cases in IoT devices. But in most cases, that was typically done by developers taking the open source version of Android, forking it and porting it to a new hardware platform, and then managing that directly themselves without really any direct support from Google. And that meant that the first two things that I mentioned, they still were able to access. They had the full Android SDK and they were able to use the developer tools. But the open source version of Android does not contain all of the inbuilt Google Play services that are also available to most mobile app developers. And there's a lot of really helpful APIs in here for working with Google services, things like location services, identity and sign-in and authentication services. All of this functionality is inbuilt on most consumer Android devices, but if you are forking Android from open source, you're not able to access those APIs. Android Things is a fully supported from Google version of Android, so Android Things devices do give you access to the Google Play services built onto that device. And that means that you also now have direct inbuilt access to a lot of Google's other popular development platforms like Firebase and the Google Cloud Platform. If you're not familiar with Firebase, it's a great match for IoT because we have things like the real-time database and Firebase Cloud Messaging. These are great, fast, low overhead ways to synchronize and communicate data between your devices in the cloud. And this is all built in using the same Android API functionality that developers use for mobile apps that you can also use in Android Things. Also with the cloud platform, we just recently announced Cloud IoT, which is it's currently in private beta, but it's a functionality that allows you to communicate using low-power messaging protocols as well as manage large fleets of devices for enterprise use cases. And all of these Google services are available to you easily in Android things because they're already designed to support Android. But beyond just building the software on the device, I mentioned that we want to go farther with this and actually build a system that you can use to easily manage these devices as you build products and try to ship them out to market. And one of the hardest problems to solve in IoT is not necessarily what platform do I choose and how do I build my application. It's once these devices have been shipped out to consumers or end users, how do I manage them? Like, how do I ship updates and software to these devices after I lose control of those devices physically? So what Android Things provides in this regard is we've just recently released the first preview of the Android Things Developer Console. And this is a web utility, you see a screenshot of it here, that allows you to manage the software that gets loaded onto your devices during development, but also to create software update packages that you can push out over the air to your devices once they've been shipped out into the field. So this ensures that you can maintain and manage the software on all of your devices, both in the factory, but also once they've gone out to consumers, so that you can ship new features. If there are updates to the Android platform, you can integrate those platform updates if you want to use new APIs. All of that functionality is available to you using the console, and it's under your control. So you're able to choose when you create a new update, when that update gets shipped, how many devices you want to ship it to. And in future versions of this console, we'll also be adding metrics so that you'll be able to see information about the devices that are in the field, like what version of your software are they running, so you can get a sense of how many devices are actually being updated in the field. But beyond just making updates easy to perform, one of the other biggest issues that's often on people's minds when they're building devices for IoT is security. So we want to make sure that not only are we making this easy for developers to do, but this entire process is managed in a secure way. And this is very helpful that we're getting a lot of assistance from what we've already been doing in Android for a very long time. So all of these updates that are managed and pushed out through the developer console are pushed out to devices using the exact same infrastructure that we use to update Android devices today. And so this is it's a mechanism that we know is secure, it's used every single day, and it's very robust and it works very well. So from a security perspective, essentially what this means is when you upload your images to the developer console, those images are signed by Google and verified on the device to ensure that those images haven't been tampered with or corrupted in any way, so that we know for certain that the software being pushed down to those devices is authentic, and there haven't been any issues in between the delivery process. Part of the way that this system works is the core operating system, which is essentially the framework and all the lower level pieces, that's managed by us. And you're only responsible for essentially building the application layer that runs on top of that. So similar to the way that you would build a mobile app if you were an Android developer. And what this essentially means is that when there are updates to the platform or there are security patches that need to be applied, it's our responsibility to make all of those changes. You know, we will push new versions of the platform as new versions of Android are released, and we will also push security patches to the console when those are available from our security team that's already working on doing that for Android. So it means that you don't have to deal with all of those lower level pieces. You only have to focus on your application. And essentially, one of the advantages of this is it also means that when it comes to platform and feature updates, you as a developer will be able to control when those updates go out to your devices. But when there's a security update available for the operating system, we can push those out automatically to devices because we are managing that entire lower level of the stack. So this means that without you having to do anything, the devices that you've shipped to the field will always have the latest security updates from Google on whatever version of the Android platform you've shipped. And you won't have to worry about ensuring that the end users have the most secure devices that is available based on all the work that the Google security team is already doing to maintain all of that work inside of Android. Another feature that I want to briefly mention here is that Android supports this A/B update functionality, which allows us to roll back updates when they have problems. This is actually part of core Android. It's not something specific to Android things, but it allows us to basically apply updates in the background into a secondary set of partitions that are not active. And this means that when we're applying updates to the device has no downtime during that process. It's happening silently, completely in the background, and all the device has to do to apply the new update is reboot the device and select the new partition. And the advantage here is, one, that there's zero downtime during update, but also if something goes wrong with that update, if for some reason the update has a bug in it and the system is not able to properly boot, or some other reason why it can't fully process that update, it will automatically roll back to the working partition. So you know at all times that the images are being delivered in a secure way, they're being verified on the device, and the device is always booting into a known good state. All right, so let's talk a little bit about hardware. So beyond just the software on the device and the deployment mechanisms for managing those devices in the field, Android Things, we also want to help facilitate you actually building the physical product that you want to use for your IoT device. So this on the slide here is just a sampling of the hardware platforms that we support. On the left there we have the Raspberry Pi, and we support this hardware platform for the maker and hobbyist market. It's a very popular board, and we love to see some of the cool things that people are building on top of this platform. But we also support a variety of other pieces of hardware that take a slightly different form factor, and I've got an example of two of them are on the right. The first one on the top is an Intel Edison board, and the one underneath is a board from NXP called the Pico. And these two boards have something in common, which is that both of these have what we call a SOM-based architecture, or a system on module. And I'll show you an exploded version of kind of what that means. So this is the Pico board here. But if you were to look closely, you would see that that development board is actually two boards stacked on top of each other. The top smaller board is a core compute module that we refer to as a SOM, or system on module. And that module has all of the core elements required to essentially run the system. The CPU, the memory, the wireless radio, storage, all of that stuff lives on that core module. And the base board that is underneath that is generally application specific. In this case, we were showing you a picture of the baseboard that comes with the developer kit. But the idea here is that when you actually take one of these devices, you would originally build your prototype on top of the developer kit, but eventually you would want to turn that design into a real custom product. And at that point, you would replace the baseboard from the developer kit with one of your own custom design that includes just the pieces that your application needs, whatever those specific sensors might be or connectors to other peripherals. I'll show you an example of how this might look here in a little bit to give you a better idea. But this is very important for a number of reasons that we'll talk about that help facilitate making production hardware as easy as possible for folks who are not necessarily hardcore electronics engineers. One of the other advantages to using this SOM architecture is it means that us as Google, we can target these individual modules with the software packages that we produce, which is often referred to as a board support package or a BSP. The software that we provide to you for these different boards targets the actual module. And the reason that that's important is because it means that the software that you write on your developer kit will be the exact same software that runs on your production device when you swap out that baseboard for a custom design. Because there's nothing on the baseboard that is specific to the images that we build. We target the modules instead. So a couple of reasons that this is important for production. One of those is that building hardware can be a relatively complex endeavor. And specifically, what I have here to kind of show off this issue is I've got a zoomed-in version of the Raspberry Pi. And if you look very closely around the HDMI label that's down there in the bottom corner, you'll see that a lot of the wires that are connected between the chip and various components, they have this sort of strange squiggle ladder-like look to them. And that's not by accident. the part of the electronics design that is required when you're building these high-speed compute boards is that a lot of the interconnect traces have to be exactly the same length. They have to be a very specific length. And if any of that is variable, the system doesn't work right. There are interference problems or other issues creep in. And so it's very difficult to get this right and very complex. And so what we like to do by pushing people towards the SOM model is basically saying that all of the complicated stuff around building hardware, let's abstract that away from the end product developer in a similar way to the way that frameworks abstract you from writing low-level code. So by building on top of these system-on modules, all of the complicated hardware that looks like this with these high-speed traces and other crazy things that you have to do, those are on the module. That's a component that you can buy and integrate into your system. The custom hardware that you have to build then becomes very, very simple, because the baseboard really only has to have a few specific things on it that you need for your application. Maybe some type of power input and a connection for any of the specific peripherals that you might want to use. Everything else lives on the module, so it simplifies the design and makes it a lot easier to build with basic electronics tools like, say, Eagle or KiCad, things that are easily and readily available in the open source community. In addition to that, though, something that not everyone thinks about when building a real product is that you also have to go through a series of certification and testing steps. So like here in the US, some of the examples are a device has to go through FCC certification for its wireless radios. Other tests that you might have to do depending on what part of the world you're selling to, UL or CSA or CE type certifications. Those are safety certifications for your power supplies and other things that are living on your board. And it's important because this testing can be not only very costly, but it can take a lot of time. And the advantage of using a SOM model is that all of the modules that we support are pre-certified for all of these various regulatory approvals. So when you use a module, for example, that module is already pre-certified for FCC on the wireless radio. So the Bluetooth and Wi-Fi radios that are on that module, those are already certified. You don't have to go through that testing process again because you're not necessarily making any changes to how that looks. And even on the safety testing side, that module is again pre-certified, so the components that you add on your baseboard are very simple to test as an add-on to the core component, so that testing is much less expensive and often takes a lot less time. So when you're taking your product to market, the costs associated with regulatory approvals are very important to keep in mind, and using these pre-certified modules allows you to get over that hurdle very quickly and easily with much less effort. All right, so those are kind of the three primary areas where we like to say that Android Things is designed to help facilitate building better IoT products and making that easier for developers, right? The software on the device, the deployment mechanisms that are easy and secure to use, and the hardware facilities that we're providing to make building custom devices easier to do. Let's talk just briefly about the developer side of Android Things. So I mentioned that Android Things is essentially Android. And that basically means that from a developer API perspective, all of the APIs that are available to you in Android are also available in Android Things. But I want to just briefly talk about how Android Things is different from Android so that you kind of have that in your head. So I've got a stack diagram up here of what a traditional Android device would look like. You've got sort of the core operating system underneath, the application framework, which is the SDK functionality there, and then all of the applications that live on top. And on a traditional Android device, you've got applications for your launcher, your phone app, messaging, contacts. All of these applications are pre-built onto the device, and they increase the size or the footprint of that image significantly. As well as, I mentioned before that we have Google Play Services on this device, which is essentially an extension to the framework that also has a significant footprint for all of the functionality that it provides to developers. So what we've done with Android Things is we've stripped out a lot of those unnecessary pieces. So in Android Things, there are no pre-built applications in the system. It's essentially just your app and the framework. And we've also stripped down some of those frameworks like Google Play Services to a more IoT specific variant that has just the APIs that are necessary or useful for these embedded use cases. And those things have slimmed down the footprint of Android significantly so that it can fit into the storage and the memory spaces on these more constrained devices. We've also done a lot of work to optimize the boot time of Android things, as well as providing much lower power functionality so that applications can better control power management than they might otherwise be able to or need to do in an Android device where they're not the only application on the system. But inside of Android things, the only app running is your app. So you basically have full run of the system. We don't require graphical displays like an Android phone, but if you would like to have one, the UI frameworks and all of those are available to you as well. All right, now we have added a couple additional APIs, though, that are specific to Android things. And these are APIs that weren't necessarily in the core framework, but are very helpful or required for building these embedded devices. So we've added two frameworks to Android things. The first is the Peripheral I/O API, and this enables you to interact with low-level interfaces on the chip from your application the same way you would any other Android API. So accessing things like GPIO, PWM, I2C, I2S for audio, SPI, and UART. All of this functionality is enabled through these APIs so that your application can interact directly with whatever the low-level peripherals are that you have connected on your prototype or in your production device. Okay, whether that's serial temperature sensor that communicates over I2C, or maybe just some buttons and LEDs that you're using for user feedback. So this is a set of APIs that you can use to talk to those interfaces directly, the way you would in other platforms. But one of the things that we've also provided is a secondary set of APIs that we're calling user drivers. And this is a piece of functionality that you may not require in your app, but it can be very helpful depending on how you've structured your development. Essentially, what the user drivers are for is they allow you as a developer to integrate your custom hardware into the standard Android framework APIs for various different subsystems. So the ones that we have listed there are things like the audio system, the input system. These are things like touch input, keyboard input, stuff like that. The sensor system, and the location services through GPS. So for example, if as part of my custom design, I added on my own custom GPS module, I could use, say, the UART framework to communicate with that module and get the location data off of it. And I could parse it manually inside of my application. Or I could use the user driver API to bind that data into the Android framework and use the existing location APIs that are already in Android to get that information instead. One of the advantages to doing this, well, there's two actually. One is that it simplifies the application side of development. Maybe you want to port some code that was written for another Android device, and so it already uses the location services. And if you could just get your GPS data into the framework, you could reuse that code without any changes. Another advantage is that if you add your hardware data to the framework, Android can do a lot of smart things on your behalf. For example, with location services, Android's location services not only use GPS for location, but they also use data from network sources like the Wi-Fi connection. And they can fuse that information together to give you a more accurate location if the framework knows about the data coming from your hardware. So in cases where you're adding hardware that fits these categories, it could be a good idea to look at adding user drivers as well to bind that data into Android and use the existing APIs to write your application instead. One of the other things that we have open sourced, and this is a library that we have up on GitHub, is the peripheral driver library. And this is something that we have provided to the community as a way of getting you up and running quickly. Basically, any of the common peripherals that you as a developer might find from maker sites like Adafruit or SparkFun or Seed, these peripherals, we have gone through and pre-written a number of drivers for the common peripherals that people are buying from those places. So stick with the GPS example. If you were to go to Adafruit and buy one of their GPS modules, you could use the GPS driver that we have written in the driver library and connect that right up to your application without having to write any additional code. So if you're looking for some of those peripherals, you might explore the library and see if the driver that you're looking for was already written in there, so that you may not necessarily, at least initially, have to go through and write some of that lower level code yourself. We're adding drivers to this library constantly over time. So, and we're also looking for suggestions on other peripherals that people might be using. So check out that library if you're interested in any of that. All right. So again, just to kind of wrap up the discussion piece here, you know, Android Things really kind of boils down to these three primary issues, right? We are trying to provide a system or a platform to developers to enable them to build better IoT products by providing them a platform that gives you the full power of really Google, not just Android, in the development environments that you use and the APIs that are available to you. On a system that is fully managed by Google, you can use all of Google's infrastructure to deploy updates to the field and all of that. As well as making sure that all of that happens in a secure manner, and when necessary, updates can happen automatically, so that the devices that are in the field and the end users stay as secure as possible, and you don't have to worry about that process at all. So this is where we kind of come to talking a little bit about Hackster. So one of the things that we're very interested in doing is we like to see what the community is building with this platform. We want to encourage makers and other folks that are interested to get started with it and see what kind of cool ideas they can build. So we've partnered with Hackster to basically foster a community where all of this stuff can happen, where you guys can showcase the projects that you're working on, you can get inspired by other projects that people have posted, and really just create a community around all the cool stuff that you can do when you have all this development power at your fingertips in this very small embedded form factor. So I'll have a link to it a little bit later, but I would invite you to visit the Hackster community that we have, the Google community that we have on Hackster, and I'll provide that link a little bit later. These images here are just examples of other featured projects that folks have already put up there. Things like an automated candy dispenser, we've got some robotics devices, some other camera-based devices using machine learning locally on the device. And so we'd like to invite you to visit that community, join the community, so that you can show us what projects you're working on, or just see some of the other cool things that have been put together there. And in that spirit, I want to quickly show you a demo of one of the projects that we posted on Hackster, which is what we call the Edison candle. So this is an example, and I'll show you the code, and I've actually got the physical device here with me as well. I'll show you that in a minute. This device essentially is an example that we put together. All the components that are used to build it are open source, so you can get the source code for the application. The board schematics are open source on Circuit Hub. You can actually buy the boards directly if you want to play around with this. And all of this functionality is, we've wrapped it up into a Hackster project so that you could kind of read through and learn how it all works. But the basic idea of this example is to kind of show you what it looks like if you were to build a production device. Right? A few slides ago, I showed you the Intel Edison Developer Kit, which was the same module on a fairly large board that had all of the I/O broken out for you to be able to work with it directly. This is basically a custom designed baseboard that strips away all the stuff that we don't need except for what specifically this application requires. And this application is a very basic application that just blinks a couple of LEDs in a flicker pattern to make it look like a simple LED candle. So it's a very simple example to sort of get started with, but because of that, we didn't really need anything on the baseboard except a way to connect to it and power it, and the two LEDs that we needed to blink. So we could create a much smaller, much less expensive to produce board that had all of those pieces on it, and then sort of build an application around it. So I'll quickly show you what the software experience sort of looks like on this board. So I'm going to switch over to my demo here. So if you've never seen it before, this is Android Studio. And the Android Studio IDE is what Android developers use to build applications, and we are using those exact same tools when we're working with Android Things. So this application that I'm going to show you is written in Java, which is the primary development language for Android Things. We do also support development using C or C++ if you want to use the Android NDK. All of the peripheral I/O APIs are supported through that mechanism as well. And we just recently announced first-class support for the Kotlin programming language, so you can also use Kotlin to develop your Android Things apps as well. But in this case, we're just going to show you the sample here in Java. So again, if you're not familiar with Android development, I'll quickly just go over some of the things. The main component inside of your application is this thing called an activity. So you could think of this as sort of the main entry point into your app, and specifically the onCreate method of that activity. So inside of this application, when the device boots up, this application will automatically launch, or if we're just going to deploy it out of the IDE, the onCreate method of this code is what's going to get called. And basically what I want to show you is how simple it was to create this little example and what that code sort of looks like. So inside of the Edison candle, we had those two LEDs, and each of those LEDs is connected to a PWM. And the PWM port, or pulse width modulator, allows us to basically vary the output value from 0 to 100%, and that allows us to control the brightness of the LED. So what this code actually looks like in practice is we're opening two connections to each of those PWM ports for the LEDs, and then we're running some code to actually vary the brightness to give that flicker pattern. So I'll give you an example of what that code actually looks like. So accessing the actual LEDs, or the PWMs, looks something like this. So if you've done Android development before, this API format will look very familiar to you because it's consistent with the way other Android APIs are structured. But essentially there's some manager service, in this case it's the peripheral manager service, where we interact with that in our application to create a new connection to individual pieces of hardware and then control that pin or that port on the system. So in this case, we're using the peripheral manager service to open a new connection to that PWM, and then control some of the parameters around it. What is the frequency, and what is the duty cycle, which is essentially how often should it be turned on, and that's how we vary that value between 0 and 100%. So with just a handful of lines of code, I can open up two connections to each one of those LEDs, the yellow one and the orange one, inside of my application. And then the other interesting thing, and this is actually something we get for free from Android, is if I were to write this application in another lower level platform, or maybe on a microcontroller, I would have to actually write the code that loops through continuously and adjusts those brightness parameters to get that sort of change over time effect that I'd like to see. But if you think about it, a change over time is essentially just an animation. And Android has a fully functional and fully featured animation framework that has all of those capabilities in it already. So inside of my application, if I just want to manage a couple of LEDs and change their brightness over time, I can use Android's animation framework to do that for me. So all I have to do inside of this code is create a new instance of an animation, tell it essentially how long to run, it needs to repeat forever, and this little thing called an interpolator is a way of defining what the path of the animation should be. So in this case, we're getting a flicker effect in our candle because of this interpolator called bounce that actually takes the value that it's animating and oscillates it a little bit at the end before it moves back the other direction. So again, with just a handful of lines of code using the animation framework, I can create these effects without having to write a bunch of loops and timers and other things along that line. Okay, so now I'll show you what this looks like running. So inside of Android Studio, I can click this little green button to run the application, and that will give me a list of all the devices that I have connected. So we can see that the Edison device that I have connected here over USB is visible. And so I can click OK, and once that application is built and deployed, I'll cover this so you can see it a little better, the LEDs should start to flicker in that pattern. So there we go. So now you can see that application running on the device, and it's a very simple application. It's just animating those two LEDs in essentially the same pattern, just offset from each other. And all of that with really just about 100 lines of code, most of which is essentially boilerplate for the framework. So there's very little code involved in getting this up and running with working with some of the basic peripherals inside of Android Things. Okay. Jump back to the slides here real quick. All right, so that's pretty much all I have for you today. Just a couple of final parting links here before we get into the Q&A. Other things that you can look at if you're interested in learning more about Android Things. One of the first places to go would probably be the developer documentation. So this is on the Android developer site alongside all of the other Android platforms I mentioned. So just developer.android.com/things. We'd like you to join our Hackster community, the Google Hackster community, so you can find that at Hackster.io/Google. We'd like you to join that community as well as, show us what projects you're working on, look at the projects that are there, and sort of start to build that level of inspiration amongst the community. And then finally, we'd like you to join the IoT developers community that we have on Google+. And this is where other developers that are working on Android Things, but also those of us on the team are also in this community, so you can use it to share information, ask questions. We're constantly in there so that we can answer questions about, why is something not working. We also have a Stack Overflow community that you just tag your question with Android Things, and we can help provide answers there as well. So that's all I have for you today. Thanks very much for your attention, folks.
Dave, thank you so much. This was really good. I also learned a ton of stuff, and there's a lot of questions that I've been monitoring. I actually was able to answer at least one, but let me go ahead and start. And we have a bunch of time to answer. So let's see. Yeah, there's a question around Nest support. Will Nest support Android Things with Weave now? Will you have full control? So a little bit about the, yeah.
So Nest is an ecosystem of devices that are made by Nest or whatever. I mean, Android Things is a developer platform. It's not a consumer platform. So Android Things is designed for people to make their own devices, whereas Nest, they sell thermostats and cameras and things like that. So Nest has their own developer platform. If you want to control devices with a unified approach, then you'd use something like the Google Assistant with Smart Home. So that is the ability for developers to integrate their own light bulbs and things like that. And Nest integrates with the Google Assistant as well. So it's that's the correct approach to integrate Nest devices with a cohesive ecosystem.
Got it. Great. Okay, give me one sec. There's a bunch. Can you talk a little bit more about your integration with your cloud offering, around something more about data collection analysis, context-driven triggering of functions?
Okay, so it's Cloud IoT, I imagine. Yeah, so so basically Cloud IoT launched at Google I/O just recently, so there was a talk there about it. So if you want to actually learn more about it, there was an entire talk for like 40 minutes about Cloud IoT, so that was quite interesting. I mean, Cloud IoT runs on many different kinds of hardware. I mean, it can run on Android Things, but it's not restricted to just running on Android Things. It's designed for enterprise deployments so that you can, it's designed for when you've got millions of sensors that are scattered everywhere, and it's designed for easy deployment so that you can scale out 1 million devices really easily. So that's the main point of Cloud IoT. It's designed to do that. So Android Things could be the operating system that it runs on, but it's not necessarily limited to that. It can run on many other things as well, because we understand that not everyone's using it, and so we wanted to make sure it ran on as many platforms as possible.
Great. Are you guys working on supporting more kits, more hardware in the horizon that you can share?
There's always more hardware coming. I mean, the OEMs are constantly coming up with new hardware designs or whatever. We don't have any exact plans to share today, but all the big device makers, that some of them have made announcements and press releases about upcoming devices, with LTE support and different things like that. So there is a whole bunch of boards coming, but we don't want to comment about plans that are not available yet.
Now, I will add one thing to that, which is this is definitely something where we want to hear feedback from the community, sort of along what platforms you want to support and maybe what your needs are and why the platforms that we don't support aren't meeting your needs. So a couple ways that you could provide that feedback. One is you can post that information in the G+ community, and another is we'll be sending out an email following this webinar that will have a survey in it, and a lot of the questions in that survey are targeted around gathering feedback on hardware support. So if you have thoughts on that, look for that and fill out the survey as well.
Yeah, that's cool. I mean, we do have a wide range of boards for different kinds of people. You know, some have got good graphics, some are small SOM-based design. So, we think we've got a lot of boards that do different things. So, really would like to learn more about what people are trying to do and what their needs are and so forth, like Dave said.
Yeah.
Awesome. RPI, Raspberry, is it only RPI 3 is being supported right now?
Yeah. So right now we only support the Raspberry Pi 3. I mean, there's a porting effort required to support every board. So, it would take a lot of effort to support Raspberry Pi 1, 2, and so forth. And it's like the Raspberry Pi 1 and 2 are obsoleted by the Raspberry Pi 3. So we're mainly aiming towards newer devices because, Android Things is a very new platform. So it's kind of, by supporting really old hardware that you can't buy anymore, it's not a good investment of our time. We'd rather spend our time on adding new features to the platform and supporting newer boards that are going to be the future of this platform. So we definitely, that's where we spend most of our time, is on that. So yeah, the boards are really cheap, so it's better if someone buys a board that's designed for that specific application. Like we get a lot of requests at conferences for, hey, I've got this board sitting around, I'd like to port Android Things to it or whatever, and the cost of porting it is incredibly high. So in some cases, it can be just easier just to buy something that works for what we're trying to do.
Makes sense. Talk a little bit about security. Are the devices being made secure in the field in Android Things, and how? So a little bit about security in the context of Android Things.
Well, Dave talked a bit about it earlier. So, I mean, one of the nice things about Android Things is that there's a big focus on security. So when the AB updates are being applied to the device, it checks the checksums of the binary package to make sure that it hasn't been tampered with along the way. Everything's done with HTTPS to make sure that there's no man-in-the-middle attacks and things. We have security updates from the Android team. So the same team that does the updates for Android also is making updates for Android Things that we can push to devices. So we're covering a lot of those things. But also a lot of new hardware devices now are coming with crypto support on board. So it's possible to actually, for the device to prove that it's a legitimate device, so you don't have to worry about your hardware being copied and things like that. So there's actually, at Google I/O, Darren Cran gave a talk about security on Android Things, and it's a really nice talk that goes for about 40 minutes where he goes through all of the details. I'm actually not an expert on security, and I learned a whole bunch when I watched that talk myself. And there's a lot of thought that's gone into it. As I said, like hardware on the device that is integrated into Android Things. So you can do things like storing your keys in the crypto chip on board so that they're not visible on the file system itself. So there's lots of different things that we're doing to help you as a device maker ensure the authenticity of your device, to protect your customers' information and things like that. So it's really, and this stuff is difficult to do by yourself because the crypto chips tend to be not documented well or hard to access or require privileged access to get to them. So we've provided APIs and the support necessary so that you can take advantage of these things without having to be a security expert yourself. Because that's the other thing with building IoT products is that a lot of people think, oh yeah, I can build my own update mechanism or my own security, but it's really hard, and if you don't do it perfectly right, then now you've got a security vulnerability. And so we take care of a lot of these things for you that really helps to make it so that you can make a secure product without having to worry about all these things.
Cool, great. Another interesting question. Let's talk about machine learning a little bit, such as TensorFlow APIs. How does that kind of work with Android Things?
Well, the nice thing, so a couple months ago, we did a blog post where we announced a sample that allows you to run TensorFlow on Android Things. So we had this little demo that anyone can try out if they want. We basically can point a camera at pictures of dogs and it'll identify the breed of them for you. So it's really cool because it takes advantage of the TensorFlow inbuilt image recognition engine that they've provided, and it recognizes animals and other objects for you, but it shows how it works on Android Things. We showed how to make a device around it to make a cool demo. But that's one of the really cool things about Android things is its ability to run TensorFlow. Because a lot of other microcontrollers, so for example, you can buy really, really simple microcontrollers, but they're simple, they're designed to blink a light or do something very basic. But the nice thing about Android things is you can run really high-powered things like image processing and audio processing and so forth. And that's where I think Android things is really going to show its strengths, is in areas like machine vision and learning and all these different things, because they require really high-powered CPUs, and that's one of the things that Android things is really good at, is providing that functionality. So I think we're going to see a lot of really exciting machine vision and learning type things coming out soon that are, it's going to be very interesting to see what kind of cool ideas hackers come up with, you know, especially on the Hackster community, of crazy things that you can do with it. Like, it's sort of, there's a lot of cool possibilities.
And kind of along those same lines, you know, Wayne mentioned that we did publish a sample of using TensorFlow locally to do inference on an Android Things device. So you can find that by just going to the Android developer site and looking up our samples. But one of the Hackster projects, it's actually one of the ones I featured on the slide, the wildlife detector, actually was based off of our sample and does the same sort of thing. It captures images of wildlife that come by and analyzes whether or not it's a certain type of animal based on the local machine learning model that's running TensorFlow. So you can look at that one on the Hackster community as well and kind of get a feel for how people are using that today already.
And it's really easy to take the sample and modify it and do whatever you want. So if you've got some crazy idea, then definitely you can take that sample, tweak it, and turn it into something like that. So there's a lot of, yeah, it's going to be very interesting to see what people put together with it.
Cool. There's a question that repeats itself a lot. Obviously, everybody wants to understand how you guys are going to handle the Edison and the whole Intel situation, and I'm assuming you're going to keep supporting the products because these products are still fine and they're going to have a life cycle probably for several years. So I don't see this as something that's going to be dropped immediately, but why don't you guys give us an official response, like how are you handling the discontinuation of the Intel product line?
Yeah, I mean, so we support all the Edison products right now. So I mean, the developer preview of Android Things has been supporting Edison and Joule and so forth. So you know, we're still working on those ports for Android Things as well. I mean, hardware makers, you know, they sometimes cancel products. That, you know, that's part of what happens in the electronics industry. But you know, every OEM is constantly releasing new devices as well. So there's a whole bunch of new boards coming out from different companies that Android Things is going to support. So yeah, it's a, I don't know, Dave, do you have anything to add?
I guess the only thing I would say is that, and we don't have anything official to announce here, we're still working with Intel, but the end of life of a hardware product doesn't necessarily mean the end of the software support for it. Right. So just because they have issued EOL notices at the end of this year for the hardware, that doesn't necessarily mean that we can't continue to support that platform with our software on into the future. Now, what that actually looks like and how long that might be, we still need to work those details out, but that doesn't mean that at the end of 2017 you won't be able to flash Android Things on an Edison anymore.
Yeah, I think manufacturers, I mean, good manufacturers, this is how they do business, is they issue end-of-life statements when they're finished, saying it's a heads up for makers so that they're not caught out, you know, planning a 5-year or 10-year production run, knowing that a device has been canceled. So the really good manufacturers will always tell you their timelines to make sure that you're aware of what's going on. But sorry, but yes, I mean, it's part of how things are. But you know, we were going to support it still. So you know, as part of the preview that we're doing, you know, we're still supporting these boards. So, yeah.
Great. Technical question: your capability to talk to Shields or Mezzanine?
Sorry, what was the question?
Is there like a your capabilities to talk to?
UART. Is there a UART?
Yeah.
Oh yeah. So I mean, I don't know which boards support it, Dave. Do you know?
All of our boards have UART support. Yeah.
Yeah.
So like the Edison, for example, right now the developer kit for the Edison is in an Arduino form factor. So you can mount shields on top of that, and the Arduino pinout for the UART, sort of on those first 2 pins, is mapped to that appropriately. So, you know, if you have Arduino shields, they would work with that kit. Some of our other kits, like the NXP kit, is based off of the Raspberry Pi form factor, so the pinout there matches the Raspberry Pi 3. And so again, UART support is in the same place. If you have a hat that would go on top of an RPi, you could use it on the RPi or even on the NXP kit, and those are all plumbed into the APIs so that you can use them.
That's the thing, and if shields are important to you, then there's a couple different options you have to choose depending on what you're trying to do. So that's the nice thing, is they're available if you want to use them.
Yeah,
cool. There's a good question here. Are you going to include an app so there will be a way to have a remote display which will assist you while you're developing?
That's something you could build yourself if you wanted to. I mean, it's just an Android device. I mean, we don't have anything plumbed into the framework itself to do remote display. But because it's Android, you could, if that was important as part of your application, I mean, and you wouldn't necessarily build a remote display. You could use something like Firebase, for example, to synchronize data to another device like a phone or a tablet. So it depends if it's for debugging or if it's part of the actual application experience itself. You do have a couple options there, but we don't provide anything in the framework itself to do that.
Yeah, and the other thing that I would say there is if it is in fact only for development purposes, many of the developer kits do support displays. I mean, if, for instance, the Raspberry Pi has HDMI, you can plug in a display, or even the NXP kits have display connectors that you could connect a small LCD to as well. So if you just want to have a display while you're doing development, then maybe you don't pin that out on your product. That's perfectly fine. And at that point, it's not even a remote display. It's just the display, and you can write data out to views if that's easier for debugging or however you want to work it.
Got it. Do you support client-server side web sockets?
As in, you want to run a web server on the device?
I guess, yeah.
I guess so. I mean, you can, because it's Android, whatever you could do in Android itself, you can start up a socket. I mean, you would have to provide your own web server, though. I mean, Android Things doesn't include a web server on the device that you can just add files to. So if you want a web server, you would need to provide the code for one and then start it up and do whatever it is that you're trying to do. So you could do something like that. It's mainly meant for running code on the device, and then you would connect to other servers on the cloud or whatever. But there's no reason you couldn't do something like that if that's what you're trying to do.
Yeah, and I guess I would add on to that by saying that we're not necessarily restricting communications to any specific type. It's not like Android Things will only communicate to the cloud through Firebase or Cloud IoT. You know, any HTTP API that you could connect to from your Android device, you can write the code to connect to from Android Things, including potentially even running a web server if that works for you. So it's the flexibility is there to connect to whatever services make sense for your app.
Cool. Now the question are, let's see, a lot of Nest support questions, so we can answer that, and we'll elaborate more on the Hackster site. Just a question about your release cycles. What version are you on right now? It's still a beta, right? When are you planning to release the second version, or
yeah, so I mean,
kind of roadmap?
Yeah, so we do developer previews every, roughly 6 weeks or so. It varies depending on what we're doing. So we've been doing those. Now at Google I/O, Venkat Rapaka gave a talk about the roadmap for Android Things. So that's a really good talk if you want to learn more about what the planning is and so forth. So right now the current plan is that Android O is coming soon for phones and tablets, but the next developer preview of Android Things is going to be based on Android O as well. So the engineering team right now is busy sort of porting everything over to Android O, because Android Things is going to be sort of moving along with Android O now, so they need to get that in sync. So that's what they're working on right now. We don't have an exact timeline for when Android Things is going to go full stable that you'll be able to make products, but it's coming soon. Venkat talked a bit about the timeline in his talk as well. So it's sort of, that's what we're working on right now, is just getting ready for Android O. There'll be another preview based on that. And then the main goal is to sort of make sure we get all the features of Android in there so that the platform supports everything that people want. And then at some point we'll have our long-term support version coming soon, but we don't have an exact date for that yet.
And just another thing to add on to that, both the Venkat talk that you mentioned as well as Darren's talk that you mentioned earlier, both of those sort of touch on the long-term support. So once we do go into stable, how long we will support each version with security updates, et cetera, et cetera. They describe what the plan is there as well. So it'd be good to watch those talks.
Got it. Cool. So, there are a lot more questions. So for everybody that did not get your question answered, I apologize, but please do go ahead and I will share it once
We'll be happy to
again.
answer them, on your forum or whatever, because at least that way the
Yeah.
answers will be there for people to see. So, we'll go through them later on and put answers as best as we can.
So I just shared for everybody, like here's the link. You can go see the project, and you can actually stay on the Google feed over there and ask all the questions that you need to be answered. There's a lot more questions again about Weave and even deeper questions about Nest. And but I'll do let's do one last question, and then we'll wrap it up. So because it is 10. There's some question about OTA, over-the-air updates with Android things, and let's see. So maybe just mention, like, how you're planning to support over-the-air updates, if at all.
Well, it's the same mechanism that we use to update, like, I don't know, Nexus phones or whatever. So it's sort of, Google has an update infrastructure that we use for that. So we can push updates out to devices. The Android Things developer console is where you go about building those update packages to push to the device. So you upload a zip file that contains an APK which has your user code in it, along with any extra little bits and pieces. You then upload that to the console. The console then builds a system image or whatever that is then pushed to the device via the OTA mechanism. So you don't have to worry about OTAs. That's the nice thing about it, is that it kind of handles everything. So a lot of people try to build their own update mechanism, then it has security vulnerabilities and all kinds of problems. We handle all that. It's a mechanism that's been tested for many years and used by Nexus phones. So it's kind of a very nice way of pushing updates to the devices. And then, as Dave mentioned earlier, it does an A/B update mechanism similar to what is currently on Android N, so that you can stage the next update, reboot into it, and then if it fails, you can roll back to the previous version. And then it makes sure the device always comes up cleanly, and if there's any problems, it goes back to the old version to make sure that your device is never stuck in a bricked state where it can't boot and get further updates. So yeah, I mean, that's basically, the system's pretty simple in concept. So yeah.
One thing that I would add to that, just to be more specific, is that if you're familiar with being an Android app developer, when you ship an app update to the Play Store, there's an app on the device, the Play Store app, that downloads the new version and updates that specific APK. This is not how that works. This is more like when your entire operating system gets a new version update or gets a security update, where the update is actually downloaded and the entire system is patched into the new version. This is that mechanism, not updating just your app like you would as a Play Store developer.
Got it. Cool.
And I guess one final thing for us. I mean, you mentioned,
Yeah.
there's a bunch of questions about Weave and stuff like that. So I'll just say something quickly about that. So I mean, in the past, Google was working on Weave. So with I/O, we announced a whole bunch of new initiatives. So we announced Cloud IoT. We announced Smart Home, which is the ability to connect devices into the Google Assistant. And so between Android Things, Cloud IoT, Firebase, Smart Home, and so forth, we kind of have enough coverage of all the different things that we need to build an IoT ecosystem of devices, both for consumers and developers. So what's going to happen going forward is that Nest, who also has Weave as well, Nest is going to go forward with doing a developer story for Weave, but that's going to be something that Nest takes on from now on. So in the past, it was sort of worked on the Google side of things. As a result of all these other things that we have, Nest is going to go forward with Weave. We have enough other software APIs and so forth that can take care of everything that developers need. So, I mean, that's mainly our strategy right now. So Nest going forward is going to have more information about Weave. They haven't said too much yet. That's coming soon. But yes, that's currently where things are at with Weave right now.
Cool. Well, great. Well, thank you very much, Wayne and Dave. This was really informative, really good, very thorough. So, and thank you everybody who joined the call and joined the webinar. As I mentioned, this webinar has been recorded, and we will follow up with a survey and a link to the recording. In the meantime, please do move your questions to the feed on the Google Hub on Hackster. And once again, thank you, everybody, and enjoy your weekend.
Cool.
Thanks
Thanks very much.